Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about the Fourier transforms. Here the Fourier transform is nothing but the transformation from one domain to other domain. So in these signals and systems, the Fourier transform is defined as it converts from time domain to frequency domain. Here the time domain signal which is represented as x of t, time domain signal which is represented as x of t, and frequency domain signal which is represented as x of omega. So transformation from time domain to frequency domain, we call it as a Fourier transform. So we have the continuous time, the Fourier transform of continuous time signal x of t is defined as, so this is the formula for Fourier transformation from defined as x of omega is equal to integral minus infinity to infinity x of t e power minus j omega t into dt. So this is the Fourier transform formula. X of t is the given signal. We have to find out the Fourier transform, that is x of omega. So in the same way, the inverse Fourier transform, the inverse Fourier transform which is equal to x of t. So x of t is equal to 1 by 2 pi. Here the limits omega limits, omega is equal to minus infinity to infinity x of omega e power j omega t into d omega. This is the inverse Fourier transform formula. So we have, there is a transmitter and there is a receiver. So here at the transmitter side we are converting from time domain to frequency domain. So after that again at the receiver side, so we have to convert from frequency domain to time domain. So here we are applying Fourier transform, here we are applying inverse Fourier transform. So this time domain signal is nothing but it's a continuous time domain, it's a continuous process, and frequency domain is nothing but which is applied to a computer system. So the computer system which is not understandable by the time domain signal, so for that we have to convert into time domain to frequency domain. After that again, after processing, the signal again is converted into a after applying inverse Fourier transform, again the signal is converting from frequency domain to time domain. Why? Because the frequency domain signal which is not understandable by the users, for that we have to convert that signal into a time domain signal. So this is the Fourier transform. Let us see the properties of a Fourier transform. We have different properties and we have to see one by one, and each property we have to prove. The first property here is linearity property. So this is the property of Fourier transform, and the first property is linearity property. So here the linearity property of Fourier transform states that, so we have already seen this equation in the classification of linear and non-linear systems, that is classifications of systems. That is nothing but the weighted sum of two signals which is equal to the weighted sum of the individual signals. So here the Fourier transform of a1 x1 of t plus a2 x2 of t is equal to a1 x1 of omega plus a2 x2 of omega. Let us see the proof of this signal, proof of this property. So we already know what is the formula of Fourier transform. This is the formula. So for every property we have to use this formula. That is a Fourier transform formula, x of omega is equal to integral minus infinity to infinity x of t e power j omega t into dt. So here you have to use this formula, that is x1 of omega is equal to integral minus infinity to infinity x1 of t e power j omega t into dt. So here I am taking the Fourier transform, that is one signal is frequency domain signal is x1 of omega and second signal is x2 of omega. Why? Because here we have two signals, it is x1 of t and x2 of t. For that we are taking two different signals. So next one. So now the Fourier transform of a1 x1 of t, this is the left hand side part. The Fourier transform of a1 x1 of t plus a2 x2 of t is equal to, so what is here in the formula x1 of t, so we have to use a1 x1 of t plus a2 x2 of t into e power j omega t into dt. So in place of x of t we have to substitute the value, left hand side part. So now separate this integration, that is nothing but integral minus infinity to infinity a1 x1 of t e power minus j omega t into dt plus a2 x2 of t e power minus j omega t into dt. So here a1 is constant, so you can write this signal as integral minus infinity to infinity x1 of t e power j omega t into dt plus a2 integral minus infinity to infinity x2 of t e power minus j omega t into dt. So here a1 is constant, so this is nothing but what? x1 of omega. x1 of omega is equal to integral minus infinity to infinity x1 of t e power minus j omega t plus a2 is constant. Again this is in the form of the frequency domain signal x2 of omega, that is a2 x2 of omega. The Fourier transform of the linearity property is what? The Fourier transform of a1 x1 of t plus a2 x2 of t is equal to a1 x1 of omega plus a2 x2 of omega. So these properties are very important for exam point of view. Even it is a JNTU-K or JNTU-H or any autonomous college, these properties are very important. Let us see the next property, that is a time shifting property. So here the time shifting property, the name itself indicates it's a shifting of time. So here the Fourier transform of x of t minus t naught. T naught is a shifting. So is it a left shift or right shift? X of t minus t naught is equal to e power minus j omega t into x of omega. Now write down the formula of the Fourier transform. This is the formula of a Fourier transform formula. We already know this, the formula. Now in place of x of t, so what we have to take in place of x of t? In place of x of t, we have to substitute x of t minus t naught. That is nothing but what? Fourier transform of x of t minus t naught is equal to what? Integral minus infinity to infinity x of t minus t naught e power minus j omega t into dt. Now let us take this t minus t naught is equal to p. Let t minus t naught is equal to p. Then what is t? T is equal to what? P plus t naught. Then differentiation of dt is equal to what? dp. Okay. Now substitute these values in this equation. Now x of t minus t naught, in place of x of t minus t naught, we have to substitute p. That is x of p e power minus j omega. In place of t, we have to substitute p plus t naught. In place of dt, we have to substitute dp. Now it is in the form of a power m plus m minus n. So you have to separate this one, that is x of p e power minus j omega p into, separate this one, e power minus j omega into t naught into dp. Now, so for after that you have to bring it outside, e power minus j omega t naught out. So remaining part is what? Integral minus infinity to infinity x of p e power minus j omega p into dp. Now, so again it is in the form of Fourier transform, that is x of omega. See, if it satisfies the Fourier transform means the variable here all are of same variable. That is, if it is a t means x of t e power minus j omega t dt. If it is any variable, that is if it is in the form of a Fourier transform, you have to take it as x of omega. So this is the frequency shifting, time shifting property of Fourier transform. Now let us take next property, that is the time reversal property. Now the time reversal property states that what? The Fourier transform, time reversal, that means reversal of time. So for example, if you take the 4 quadrants, this is t. So this is t means time reversal means folding. This is minus t, right? That is time is reversal. That means x of minus t is equal to x of minus omega. So we have to prove this one, x of minus t is equal to x of minus omega. First you have to write down the formula for Fourier transform. That is x of omega is equal to integral minus infinity to infinity x of t e power minus j omega t into dt. Now let us take, let t is equal to minus t. So in place of t, you have to substitute minus t value. Now minus t e power minus j omega t into dt. Now minus t is equal to, let minus t is equal to p, then dt is equal to what? Minus dp. Now this is very important. At t is limits are very important. If you take, what are the limits here? The t limits are from minus infinity to infinity. Now we have to find out the limits of p. At t is equal to minus infinity, what is the lower limit? Minus infinity. Here take this condition, that is t is equal to what? Minus p. If t is equal to minus p, what is p is equal to? Here t is equal to what? Minus p, right? Now what is t value here? Minus infinity. Minus into minus plus infinity. That is what value? P value. P is equal to infinity. What is the next value? T is equal to infinity. Here t is equal to infinity means, again t is equal to infinity means p is equal to minus infinity, right? Now you have to change the limits. The limits here, the t limits are from minus infinity to infinity. Now the p limits are for infinity to minus infinity to minus infinity. So here I am changing the limits, infinity to minus infinity. Now what is minus x of t? Minus t, that is p. Here you have to substitute p value. Again, next, e power minus of j omega of, in place of t, what is the value? Minus p, right? In place of t, you have to substitute minus p value, and dt is equal to what? Minus dp. So you have to substitute minus dp value. Now this equation can be written as integral infinity to minus infinity. Here this minus, keep it outside, x of p e power minus j. This minus, you have to put this to omega, minus omega of p into dp. Now if this condition, if the Fourier transform definition is satisfied, means this is not in the form of the Fourier transform, because here the limits are starting from infinity to minus infinity, but the Fourier transform limits are for minus infinity to infinity. For that, if you remove this minus, again you have to change the limits minus infinity to infinity. Okay, so now integral minus infinity to infinity x of p. If you remove that minus, you have to change the limits minus infinity to infinity x of p e power minus j omega minus omega in p into dp. So in place of omega, what is the value? Minus omega. So this is nothing but what? X of minus omega. So this is the time reversal property. Let us see the next property, that is time scaling property. Scaling is nothing but we have to scale the time signal. So that is, by definition, the time scaling property states that the Fourier transform of x of at is a scaling, is equal to 1 by a x of omega by a. Now here write down the first formula of Fourier transform. So you already know that one, the formula, Fourier transform formula. After that, in place of x of t, you have to substitute what? X of at. X of at e power minus j omega t into dt. Now let at is equal to p. Now t is equal to what? P by a. Now dt is equal to what? dp by a. So now in place of at you have to substitute p. In place of dt you have to substitute dp by a. Now in place of t you have to substitute p by a. So after substituting all these, you can get this equation. So x of p e power minus j omega of t value is what? P by a, and dt value is what? dp by a. Here 1 by a is constant, right? So you have to keep outside. Integral minus infinity to infinity x of p e power j of minus j of omega by a p into dp. Now it is in the form of, here in place of omega, what is the value? Omega by a. So that is nothing but 1 by a. So this is in the form of x of omega by a. So this is the proof of a time scaling property. Proof of time scaling property. Now the next property is frequency shifting property. So we have seen the time shifting property, right? Time shifting is nothing but we have to shift the time. That is what we have said, x of t minus t naught. Here is what frequency shifting. So I already told the Fourier transform is nothing but converting from time domain to frequency domain. Time domain which is represented as t and frequency domain which is represented as w. That is nothing but omega. Now here we have to shift the frequency, that is Fourier transform of e power j omega naught t x of t is equal to what? X of omega minus omega naught. Now first write down the formula of Fourier transform. So this is the formula of Fourier transform, x of t e power minus j omega t into dt. Now after that, so what is x of t value? In place of x of t you have to substitute this one. So x of t e power j omega naught t into e power minus j omega t into dt. Now here it is in the form of a power m into a power n. Now you have to write a power m minus n. That is nothing but x of t e power minus j is constant. So minus j is common. Omega minus omega naught into t into dt. Now in place of omega, what is the value here? Omega minus omega naught. That is Fourier transform of x of t e power j omega naught t is equal to what? X of omega minus omega naught. So this is the frequency shifting property. So we are shifting the frequency. Now let us see the next property, that is time differentiation. So this time differentiation property states that differentiate the time domain. Time domain is nothing but what? X of t is equal to j omega into x of omega. So now first you have to write the formula for a transform. So after that you have to substitute in place of x of t differentiation of d by dt of x of t. You have to substitute d by dt of x of t e power minus j omega t into dt. Now in this differentiation, it is you have to rearrange this one, that is e power minus j omega t into d by dt of x of t into dt. Now it is in the form of integral uv. So what is uv formula? uv is nothing but u into integral of v minus integral of differentiation of u and integral of v. So by using this formula we have to write down the equation. First u is what? E power minus j omega t. First this is u. Next integration of v. Integration differentiation getting cancelled. We are getting only x of t with limits minus infinity to infinity minus integral of differentiation of u. Differentiation of u is what? U is what? E power minus j omega t. So differentiation of e power minus j omega t is what? Minus j omega into e power minus j omega t into integral of v. Integral differentiation getting cancelled. We are getting x of t into dt. So now after that substitute the limits. So first upper limit minus lower limit. You have to substitute the upper limit, that is infinity, x of infinity minus x of minus into minus plus infinity, x of minus infinity plus j omega. Minus into minus is plus j omega, keep it outside. So remaining part is what? Minus infinity into infinity, x of t e power minus j omega t into dt. Now here what is e power minus infinity value and e power x of minus infinity value? Both are zeros. Now this value is 0 and this value is 0. So we are getting only, that is j omega into x of t e power. We are getting only e power j omega integral of this one, x of t e power minus j omega t dt is equal to j omega into x of omega. So this is nothing but what? Fourier transform. That's why here is this one is x of omega. Now the differentiation of the time domain signal, here we are getting j omega into x of omega. So these are the properties of Fourier transform. So if you like my video, please share, like and subscribe. Thank you.